Okay, so ladies and gentlemen, welcome to our physics class. So for our new members, this is Dr. Possibility, and in today's class I'm just going to look at the topic which is called momentum and impulse. And this is a physics lecture class, and this is our part 1. That simply means that in this lecture class I'm just going to focus only on the theory side of this topic. I'm not going to have any calculations, but I'll only explain the theory side of this topic. So feel free to ask questions and feel free to participate. So there is an animation there which I have played. There is a gun which has been fired, and that gun has released a bullet, and this bullet has managed to penetrate through a glass, through a thick glass. And then this thick glass had to break, but we are not really going to talk about it, but we are going to talk about the concept behind this. So this gives us a topic which is called momentum. So when you talk of momentum, momentum is just the product of mass and velocity. Momentum is just the product of mass and velocity. So from that definition, we can come up with an equation, and this equation is linear momentum is simply equal to mass times mass of the body times the velocity of the body. So the mass of that body and the speed or velocity at which that body it is moving. So momentum can just be said to be equal to mv. So momentum can be said to be equal to mv. So since momentum is the product of mass and velocity, so momentum is simply a vector quantity. So momentum is a vector quantity, and it being a vector quantity, it simply means that it has a direction and magnitude, of which the direction is the same as the velocity. The SI units of momentum are kg per meters per second. So kg meters per second. The kg is coming from the mass, and meter per second is coming from the velocity. We can quickly move on and relate momentum to inertia. So if you look at inertia, according to what we learned when we are talking about Newton's laws of motion, we said inertia is the ability of an object to resist change in its motion. Like an object doesn't want to stop moving, like this car and the lady there. So they have to keep on moving. They have to keep on moving unless an external force acts on them. But there is a relationship between inertia and momentum, such that when there is more momentum, it is very hard for an object to change its motion. It's very hard for an object to change its inertia. So more momentum means more hardness in stopping an object or in changing the motion of an object. Imagine yourself standing in front of this car and trying to stop it, which is 100% impossible. You're going to be killed. So same applies with you standing in front of a moving truck. It will kill you. Why? Because it is moving, or it is having a high momentum, which is due to the mass and the velocity it is moving at. But if you get a toy car, no matter the speed it will move at, you'll be able to stop it, because it is having what? Less momentum due to the speed and the mass. One other thing I can talk about is a bullet. You can't stop a bullet. Why? Despite it having a small mass, it has a very high speed, and that speed, which is the velocity, it is very hard for you to stop it because it is having a high momentum. So greater effect it will have, or if an impact or collision take place, if an object or a car is moving at a very high speed and then it collides with another car, we have seen a lot of accidents happening. Maybe a car hits into another car or hits into a tree. We see a lot of damages that are happening, or that it's because of the momentum which that car is simply moving at. Then a force is required to change an object's momentum. Okay, a force, like I have said, an object will keep on moving in that particular direction and at that given speed or at that given velocity or momentum, unless there is an external force which is there to change in terms of speed to increases or decreases. So that's what you need to understand when you talk about momentum and its relationship with inertia. With that being said, let's quickly look at impulse, because I have mentioned something like a force is needed for an object to change its momentum. For an object to change its momentum, to change its direction, to change or decrease the momentum at which it is moving, there is a force which is needed. So when we have such in mind, we can easily go and look at the impulse. Now, what is impulse? So impulse is defined as the force times the time over which the force acts. That's the equation for impulse. Impulse is equal to Ft, F for force and T for time. Or impulse can be explained as the change in momentum. Impulse is also said to be the change in what? In momentum. So for an object to change its momentum, for its momentum to increase or decrease, it's because there is a force that has acted on it at a specific time, and that force with that time has resulted into a change in what? In momentum. So that's what impulse is, or how easily you can define impulse. Okay, from there we can look at conservation of linear momentum. One thing that you need to understand is, if an external force acting on a system of object is zero, that simply means that the vector sum of momenta of object will remain constant. If the vector sum of all the forces, okay, all the forces acting on an object, then that object will keep on being at rest, or it will keep on moving at that constant acceleration. Why? Because there is no resultant force. Remember, force is a vector quantity. Okay, at this moment I would allow people to ask questions if you have questions. Any question? Any question?
Like as Yes, Professor, I did get what the introduction of momentum at first time when you were starting explaining.
Momentum is just the product of mass times the velocity. That's the definition of momentum. The products. So meaning you're multiplying time, you're multiplying mass and the velocity. Is that okay?
Sure.
All right. So let me quickly move on and look at okay, I think there is a hand. Yes, what's your question? The person who has raised their hand. Chimuka, what's your question? Evaristo, you have a question? Yes.
Yes, I think I just need more clarity on the part where you explained about the relationship between inertia and momentum. Maybe I give an example, another example that will help me understand personally.
Okay. The relationship there. So what we are just trying to do is we'll first define what inertia is. Inertia is the ability of an object to resist change in its motion. Okay? Then momentum is the product of mass times the velocity. That simply means that when an object has a high momentum, or when an object is moving at a very fast speed, that makes that object to be so hard in terms of stopping it. So it's very hard to change the motion of an object when it is moving at a high speed and when it has a larger mass. You get that now? Evaristo?
Oh, clear, sir. Thank you so much.
You're welcome.
Clear, sir. Thank you.
Okay, so let's move on and look at in collision, what happens in collision and explosion. If you look at the first animation in my video, I just played a picture where there was an explosion which took place. So let's understand what happens in collision and explosion. So the vector sum of momenta just before the event equals the vector sum of momenta just after the event. This is during collision and an explosion. So the vector sum of momenta of the objects does not change during the collision or explosion. They are just constant. So with that being said, let's say we have two bodies with masses m1 and m2, and when these two objects collides or they undergo a collision, the formula will be total momentum before should be equal to total momentum after the impact, which is m1 times u1. So m1 is the mass of the first object, u1 is the initial velocity of the first object, plus m2 times u2, which is equal to m1 times v1 plus m2 times v2. So this is the basic formula of momentum when you talk of during collision and the explosion. The sum of the momentum before the impact is equal to the sum of momenta after the impact. Now, one thing that you have to understand is that momentum is a vector quantity. Momentum is a vector quantity. This simply means that you have to consider the components of each velocity. And when you talk of the x component, it can be written the way I'm writing there. m1 u1 x, meaning the x component of the initial velocity of m1. Then m2 times u2x, which is the x component of the initial velocity of body 2. Same applies with the final velocities. So when you're making calculations, make sure that you consider the vector component. Then the y components, that's the formula. It's just similar to that of the x component, just that this time around we are considering the y component. If it was a z component, we'll still do the same thing. So we are separating these components because of the fact that momentum is a vector quantity and its direction is the same as that of the velocity. Okay, now let's quickly look at the types of collisions. Let's quickly look at the types of collision. Now we know what momentum is, we know what impulse is, we know what happens during collisions, but we have to know the types of collisions. So there are a lot of types of collisions that you are going to learn, but I'm going to stick to the most important ones. So there are many types of collisions, like I've already stated, but I'm just going to focus on the most important ones and what they are. The first one is the elastic collision. During elastic collision, both momentum as well as the kinetic energy are conserved. During elastic collision, both momentum as well as kinetic energy are conserved. During an inelastic collision, that's another type of collision. In elastic collision, this one, only momentum is conserved. Only momentum is conserved. That simply means that the kinetic energy is not being conserved. Then this inelastic collision can also be said to be perfectly inelastic collision. And in this collision, the kinetic energy is lost, resulting in the collision object to stick to one another after the collision. So the perfect inelastic collision, the objects, they tend to move together, they stick together. I'll explain more as we go on. So let me specifically now look at elastic collision. So remember, the basic collisions that I've talked about are elastic collision, inelastic collision, and perfectly inelastic collision. Now, in the elastic collision, like I've already said, both the momentum and the kinetic energy are conserved. This simply means that the first part is the initial velocity, the initial velocities, the initial momentum, the initial momentum is equal to the final momentum. The summation of the final momentum is equal to the summation of the initial momentum before and after collision. Just the same thing we have done. Same applies with the kinetic energy. The summation of the initial kinetic energy is equal to the summation of the final kinetic energy. So during a collision, when there is a collision like this one, you have to understand that this object and that object, they will hit each other, maybe they will bounce back. So that means that the kinetic energy has been conserved, and there is also conservation of energy, which has been conservation of momentum, which has also been conserved. So mostly a question like this one, it will need you to look for two variables which are not there, and you have to look for them. We'll talk more during the calculations. Elastic collision, I will give one more explanation. So in an elastic collision, bodies do not stick together. In an elastic collision, bodies do not stick together. And then the equation used for elastic collision is as follows, which is m1 v1 plus m2 v2 initials is equal to m1 v1 f plus m2 v2 f. So ff is final, ii is the initial, which is just simply explaining the conservation of momentum equation. Remember, these bodies will not stick together like you have seen in that particular animation. If you look at what is playing on your screen there, those two bodies are not sticking together. Those two bodies are not sticking together. So because they are not sticking together, this is an example of an elastic collision. Same applies with these two. If you look at those two, they have acted as if they have stuck together, but they haven't. One has gone has passed the other one. One has passed the other one. They came there, and then they went as if they are going together, but one has passed the other. The other one is the one I have just demonstrated, whereby they just hit each other and then they go back to where they came from. So both of these animations I've demonstrated here, they are just simply talking about the elastic collision. Energy is conserved, momentum is conserved, and these objects do not move together. Okay, so when you are making calculation for elastic collision, mostly there are two unknowns to solve for, and so you need two equations. Okay, so the first equation is the kinetic energy equation, which can seem to be difficult to use in most cases, and then the energy equation along with conservation of momentum can be used to solve for the two unknown. Okay, then one thing that you need to understand that for that to be explained later on, let me quickly look at the inelastic collision. So when you talk of inelastic collision, the objects, the colliding object, they normally stick together. The objects, they normally stick together, like the way I'll demonstrate later on. And then the equations which are being used is simply that equation. Since they stick together, the final velocity is the same. Since they stick together, the final velocity is the same, and then the mass is simply the summation of the two. Okay, so from that, this is an illustration of an inelastic collision. If you look there, they have stuck together and they are moving together. Then the other one you can look at is that one, whereby the track has has collided or has connected with the trailer, and then they go further and they move together as one. So that's a demonstration of inelastic collision. Okay, same there. This is elastic collision. There are a lot of questions which talk about the billiard balls. I don't know if my pronunciation is okay. So like when playing pool table, when you're playing pool table, there is such movement which you normally see. So when you hit a ball and that ball goes to the other direction, what is that ball which had to hit that ball you are targeting at goes in the other direction, that's an elastic collision. Okay, think that has been explained. There is also elastic collision, like in case of a gun. Let's say for this one is elastic recoil collision. We are going to have certain examples where we will talk about a gun, a bullet, and many types. So like that one, let's say a gun has been fired like that, that's an elastic collision. So in that case, this is an elastic collision. Another one you can talk about is that trailer, I don't know how you call it, and that one, it's also an elastic collision. So this is an elastic collision, recoil elastic collision. In elastic, like let's say you fire that one and then they go together, the bullet stick into something, like whereby in this case a bullet has gotten stuck into that ball. So in that case, this is an inelastic collision because they have gone together. So this is an inelastic collision. We have questions like an explosive bowling ball. You are given that towards a gun and shown that the gunman hopes to keep the ball away by shooting a bullet of that into the ball. So we are going to have such questions later on, which I'll give in our calculation, so you'll be able to understand more the concept behind that, of which we know these are the formulas which I've already explained. Same applies with the same guy. This one has already been demonstrated again. This is also an inelastic collision. So here the head part of the truck and the trailer, they are separated, but the head will go toward the trailer and later on they will move together. So this is an inelastic collision, and the equations I've already explained them, that's why I'm ignoring them. Okay, so with that, I'll give you assignments. So here your assignment is simple. You'll be able to identify the number and type of collision in the animation below. So the first animation is this one. Please check out and tell me what type of collision is this. What type of collision is this? So this is your first question and this is your first assignment. The other one, it is this one. Identify the number and type of collisions in the animation. So let's quickly look at that guy. There you go, and there it goes like that. Okay, so we can simply have that as our second animation. You tell me what kind of collision is this. The other one is this one. This one, we'll see it in our solvings in most of the questions. So I'll give you to identify that. Let's quickly look at that. There it goes. Okay, so we have that, and then it goes like that. I hope you guys have seen how it's happening there, and then it goes like that. So you tell me what type of collision is that? What do you think? Is this elastic collision? Is it inelastic collision? Or is it perfectly inelastic collision? Let's look at that guy again. Let's quickly look at that one again. What type of collision is this? There you go. The guy goes like that. From there, the guy goes like that. What type of collision is this? What do you think this type of collision is? So you tell me afterwards. So I think that's it for momentum. If you guys have questions, you are free to ask me now, and for those who are going to have questions afterwards, you are free to WhatsApp me.